Hello and welcome back to K-Nearest Neighbors with Python. So today you've been given a classified data set from a company, but they've hidden the feature column names, but you are given the data in the target class. So we'll try to use KNN to create a model and predict the class for a new data point based off the features. So I have imported some libraries here, pandas, numpy, seaborn, and matplotlib. And also I have typed in the data path. So we'll be reading the CSV file called classified data, and I've also set the index column to 0. I hope you do remember what does that mean. Okay, so set the index column 0 to 0 is to use the first column as the index, right? Okay, so now let's take a look of the data frame. Okay, it looks like we have some random the column names. As the question said, will be there will be hidden the feature column names, right? So we only see those 3 random letters of the column as the column names, and also some floating points, but we don't know what do they mean. The only thing we know is we got a target class 1 or 0. That's the one that we have to predict. So if you have attended any kind of the interview for data analysts or data scientists, you will be given some take-home projects to do some data analysis and machine learning algorithm, but they won't give you any of the information thing. So like you're just gonna read some random numbers or random column names, right? But it won't be a big deal, right? If we know what should we predict. I just consider the rest of the column names here, right, as features, right? We're gonna use all these features to predict the target class, okay? So the first thing here, I assume that you have done sort of review on KNN. So if I'm giving you the test observations, we're gonna by identifying the observations that are nearest to it. Okay, we can predict the class of the given test observation. So in this case, the scale of the variable doesn't matter. I would say the scale of variables matters a lot. Okay, any variables that are on a large scale will have a much larger effect on the distance between the observations. Okay, so the good way for us, okay, to do is to standardize all the variables here. Okay, in our case, you can see we got some floating points, 0 point something or 1 point something. Doesn't seem like it seems like they are pretty close to each other. But in most cases, you won't be given those kind of numbers that are pretty close to each other. So I always suggest you to do standardization first. Okay. So the good news is scikit-learn, they do provide the library that help us to do that. So let's input the library. So sklearn dot pre-processing. I hope I didn't type anything wrong. Oh, sorry. Import is called standard scalar. Okay. So now I'm gonna create an instance object. So then I can call the method here. So standard scalar is the method here. Okay, so I've created an instance object. So now I'm gonna do is I will fit this scalar object to my feature data frame. So it will be these feature columns, right? So scalar.fit. Okay, how to represent all these feature columns? It'll just be the whole data frame, but the last one, right? So we're just gonna cut this one off. So So it'll be data frame dot drop. Okay, so the last one is called target class. Okay, and don't forget about how to set the access to 1. Okay. So what should we do next? So I'm gonna do some transformation here. So the transformation is still based on the feature columns. Okay. So I will declare a variable named scaled features. Okay. So this will be the variable name after we've done some transformation. Okay. So it'll be scalar dot transform. Okay, so what should I put in my parentheses? Exactly the same thing. Okay. Alright, does that make sense? So if we take a look at the scaled features here, okay, so it comes out an array, n-dimensional array or 2-dimensional array here. Right? So these are some floating points here, and what I want is I don't want an array form. I want you to transform that to what I want is a data frame. Okay. Oh, that is. So I want a data frame form. Okay, so if you remember that in the pandas library we've done that. So call pandas, how to transform a data frame, how to transform an array to the data frame. pd.dataframe. Okay, and then what should I do? I'm just gonna pass. This is the array. Okay. And also I am gonna set the columns to df.column. Okay, so tell me what does this mean? What does this mean? So it just like I will take a list of columns as the column names, right? I hope you do remember that. So these are the list of column names, okay? But I don't want the last one. I don't want the last class. Remember how to do that? Okay, colon -1. Okay, just I don't need the last one. Okay, so let's use this to replace this one. Okay. Now we can take a look of the okay. So these are the feature columns after standardization, after transformation. So we got all these feature columns here. Okay, so the data is ready to be used. So the next part we're gonna talk about train, test, and split. Okay, we're gonna put this into the machine learning algorithm.